In this video, we're going to look at the difference between electrolytic solutions and non-electrolytic solutions. So, water by itself is not a great conductor of electricity. While it's polar and the molecules interact with each other and have partially positive and negative ends, it doesn't have the ability to conduct electricity. However, when you add some sodium chloride to it, you can see that the solution becomes capable of conducting electricity, as you can see by the light bulb giving off more and more light as the solution becomes more and more concentrated with the salt. However, if I remove the salt and I try to do that with sugar, what we'll see is that it doesn't increase the conductivity of the solution, making it a non-electrolytic solution. So why is that? Well, in order to answer that question, we got to first take a look at water. So water is a polar molecule where you have a partially negatively charged oxygen end, oxygen being more electronegative than hydrogen, and a partially positive hydrogen end. So when we put sodium chloride in water, we go from having a crystal lattice, as we know ionic compounds do, and with soluble ionic compounds, they break apart as you form the solution. And what will happen is the negatively charged ion, the chloride ion, interacts favorably with the partially positive hydrogen end of the water molecule. The sodium ion, which you can kind of see it happening here, interacts favorably with the partially negative oxygen end of the water and becomes surrounded by those ions. And when this occurs, that enables the solution to conduct electricity, which is really just a flow of electrons. If you have positively charged ions, is going to flow at high enough concentrations in the solution. What can happen is the electrons can essentially hop their way across the solution and then complete the circuit that you saw in the other animation. However, when we try that with a sugar solution, or dissolving sugar, this is a sample of sucrose here, the sucrose can break apart in its crystalline structure, but notice that none of the covalent bonds that exist within the molecule break, and it doesn't result in the formation of any ions. And as a result, the solution is not capable of conducting electricity. Now, the reason things that are sugars and glucose and sucrose and all those things can dissolve is when you look at their structure, they have O's directly bonded to H's all around the molecule, making it super soluble because there's hydrogen bond going on between the water molecules and that of the sugar, which is why you can dissolve so much of it in the solution. However, if you had something that was nonpolar, such as oil or gasoline, it doesn't dissolve in water very well because those molecules don't have partial positive and negative regions to interact with the water, and the water would much prefer to interact with itself, while the oil droplets or gasoline would kind of stick together with itself because it has London dispersion forces going on, but it doesn't have the hydrogen bonding that the water would have with other water molecules.